Good evening, and welcome to Story of the Cosmos. Tonight, we follow a handful of Soviet spacecraft into the one place in the solar system built to kill them on arrival. On the 1st of March, 1982, a probe called Venera 13 dropped through the clouds of Venus and touched down on its surface. And then, it simply kept transmitting. For 127 minutes, it sent data back to Earth, nearly 4 times longer than the 32 minutes its own engineers had designed it to survive. Think about what that means. Every gauge, every calculation made before launch said this machine would have perhaps half an hour on the ground before Venus finished it. Mission planners expected 32 minutes, and then silence. Instead, Venera 13 kept working for well over 2 hours, sending readings back from a place that seemed built to erase them within minutes. That borrowed time is where this story begins. Not with the landing itself, but with everything that had to fail first, decade after decade, before anything the Soviets built could survive on Venus at all. Spacecraft crushed. Signals lost mid-descent. A slow, patient climb toward 2 hours that no one, at the start, thought was even possible. This is where the 2 hours start. Lead melts at 327 degrees Celsius. The ground under Venera 13 sat near 460, hot enough that the metal would have run like water long before any human hand could have touched it. And that heat barely comes and goes. There is no dawn cooling, no winter lull worth the name. The thick air spreads the warmth so evenly that night on Venus is nearly as hot as noon. The weight above that ground is just as strange, nearly 90 times the air pressure we feel at sea level here on Earth. Close to what a diver would feel 900 meters down, except there is no water. Only a thick, restless ocean of carbon dioxide, wrapped so tightly around the planet, it never really thins. Which makes for an odd little fact. Mercury sits twice as close to the Sun as Venus does, closer to the furnace itself, and yet Venus is hotter. Not because more light reaches it, because the heat that does arrive struggles to leave. A thin, airless world like Mercury simply lets its warmth radiate back out into the dark. Venus holds on to its warmth. Its deep blanket of carbon dioxide lets it slip away only slowly, grudgingly, and so the surface bakes hotter than Mercury ever does. The first spacecraft to ever reach the surface of another planet arrived already silent. Venera 3 struck Venus on the 1st of March, 1966, the first human-made object ever to reach the surface of another planet. But contact with it had failed 2 weeks earlier, somewhere in the dark between Earth and Venus, and it fell the rest of the way without sending back a single measurement. A historic first, arriving in total silence. Venera 4 fared only a little better. It reached the planet in October of 1967, the first probe ever to transmit data from inside another planet's atmosphere, readings of pressure and temperature climbing as it fell. Its hull had been built to withstand roughly 25 times Earth's atmospheric pressure. Venus asked for more than that. Somewhere between 25 and 28 kilometers above the ground, still high above the surface, nowhere near arrival, the vessel gave way. 1 day later, an American spacecraft, Mariner 5, swept past Venus without stopping at all, reading the atmosphere during its flyby by watching its own radio signal bend and fade as it slipped behind the planet. Its numbers and Venera 4's told the same unsettling story, arrived at from 2 directions at once. So the following spring, in the middle of the Cold War, American and Soviet scientists sat down together at Kitt Peak Observatory in Arizona and published their findings side by side. Two rival space programs, briefly, comparing notes on a planet that had already defeated them both. It would take years yet to land and live. Venera 5 was built to fall faster than the probe before it, so it could sink deeper into the sky before the sky crushed it. Launched just 5 days apart in January 1969, Venera 5 and Venera 6 each carried a parachute smaller than their predecessors, trading a slow, careful descent for one that plunged harder and faster toward the ground. It worked in a way. Venera 5 pushed to about 18 kilometers above the surface before the pressure outside climbed past 27 times what a person feels standing on Earth, and its hull gave way. Depth on Venus meant heat as much as it meant weight. 50 minutes of data, then nothing. Venera 6 followed almost the same path to almost the same end. Neither reached the ground. But each dive told engineers a little more about exactly how much the planet could take before it broke a spacecraft in two. Then, on the 15th of December 1970, Venera 7 fell toward Venus, wrapped in a parachute that tore, partway down, in the thick air far above the surface. For a while, no one on Earth heard anything at all, and the mission was quietly written off as lost. They were wrong. Buried in the noise of an already faint signal, engineers later found 23 minutes of data, transmitted at barely 1% of its normal strength, recorded from the surface itself after landing. No image, no color, just a whisper, proving something had lived long enough to speak. Venus had finally been touched and survived. On the ground, the daylight was no brighter than an overcast afternoon back on Earth. Strange, for a world orbiting so close to the Sun. This was Venera 8, landing on the 22nd of July, 1972. And this time, the lander did more than survive. For 50 full minutes, it measured the furnace directly. A temperature of 470 degrees Celsius, give or take a few, and a pressure 93 times what we feel at sea level. Numbers that had reached Earth only once before, through Venera 7's faint, failing whisper 2 years earlier, now came through cleanly, for nearly an hour, and settled into fact. But Venera 8 carried one more surprise. Tucked among its instruments was a gamma-ray spectrometer, quietly reading the radioactivity of the rock beneath it. What it found resembled basalt, or perhaps granite, the kind of rock that usually forms when a planet's crust has separated and evolved, layer settling from layer, the way Earth's has. Perhaps Venus was not simply raw material, frozen in place since its birth, an early hint of a world with layers, like ours. For 9 years, no one had seen the ground itself, only measured it, blind, through instruments alone. Then, on the 22nd of October 1975, Venera 9 changed that. It arrived not as a single machine, but as two, an orbiter that would catch and relay whatever its companion found, and a lander, sent down to touch the surface and look outward if it could. Its cameras could not simply point a lens at the world outside. The heat and pressure would have destroyed anything exposed directly to it. So Venera 9 looked through a periscope instead, a small mirror scanning back and forth behind a porthole of thick quartz, the one window strong enough to hold back 90 atmospheres and still let light pass, building its picture one thin line at a time, the way a hand might trace a landscape rather than glimpse it all at once. One of its two lens caps refused to eject, so when the image came back, the first photograph ever taken from the surface of another planet, half of it was simply blank, a void where a second view of Venus should have been. But the half that did arrive was enough to unsettle expectations. Scientists had imagined a landscape smoothed by the weight of the atmosphere above it, rocks rounded and slumped like stones worn down at the bottom of a river. Instead, the camera found something sharper. Slabs with clean, unweathered edges, some 30 or 40 centimeters across, scattered near the base of a low hill, looking almost freshly broken rather than ancient. Half a photograph, and still an entire discovery. And so it rests. 2 more landers reached Venus's surface in December 1978, and both of them arrived blind. Venera 12 touched down first, transmitting from the surface for 110 minutes, on a world built to silence it in far less. Venera 11 followed 4 days later, returning data for 95. And on both, the very same fault struck. The protective cap meant to guard each camera during descent failed to release. The eye stayed sealed shut. 2 working landers, sitting for well over an hour and a half, combined on another planet's ground, and neither one sent home a single picture. But each carried a second way of sensing the world outside its hull. An instrument called Groza, Russian for thunderstorm, pairing a simple loop antenna with a microphone. As the 2 spacecraft fell through Venus's clouds, Groza began registering something no one had planned for. Thousands of sharp electrical pulses, clustered and rhythmic, in the same very low frequency range that lightning leaves behind on Earth. No camera had ever caught a flash on Venus. No mission since has confirmed one either. Still, something up there was recording a storm no one could watch. Before Venera 13 ever reached the surface, it was already colder inside than a winter night on Earth. Engineers had chilled its interior to -10 degrees Celsius on purpose, so that when the heat began flooding in, it would have farther to climb before anything failed. Packed around its electronics was a sealed mass of lithium nitrate, a salt that, as the heat pressed in, began to melt, slowly, absorbing the fury of Venus 1 degree at a time instead of letting it through all at once. It was not a shield in the ordinary sense. It was a countdown, engineered to run as slowly as physics would allow. Design called for 32 minutes. Venera 13 transmitted for 2 hours and 7 minutes, nearly 4 times the life its own engineers had dared to promise. In that borrowed time, it did more than survive. It looked. Its cameras, the first ever to see Venus in color from the ground, sent back 2 panoramas of a landscape the color of rust and ember, flat slabs of basalt under a sky the color of old brass, thick with sulfuric haze. No one on Earth had ever seen Venus in its own colors before that afternoon. A drill bit into the rock beneath it, pulling a sample up through a sealed airlock into a chamber built to study it in something closer to Earth conditions. Cool enough, brief enough, that instruments could work almost as they would have at home. Inside, the sample turned out to be basalt again, rich in potassium, one more small confirmation that Venus and Earth were shaped long ago from similar stone. And a microphone caught the sound of wind, the first sound ever recorded on the surface of another planet. A whisper, really. 0.5 meter per second, no more than a light breath moving across stone that could melt lead. Its twin, Venera 14, landed 4 days later nearby, in hotter, higher pressure terrain, and returned 57 minutes of data from the surface. Its own trouble began at once. Its own ejected lens cap settled directly beneath its soil testing arm. The arm lowered exactly as commanded and dutifully measured, with great precision, the give of Soviet plastic, rather than the ground it had traveled 200 million kilometers to touch. Even that small human error carries its own meaning. Every recording, every image, every fumbled reading came from a machine that was never built to think in hours at all. 2 hours once was enough. Two silver balloons drifted through the clouds of the planet that kills landers in minutes, and for 46 hours they simply floated. They belonged to Vega 1 and Vega 2, twin spacecraft that had each dropped a lander into Venus's atmosphere and released something new alongside it, a helium balloon just over 3 meters wide, carrying an instrument package light enough to lift on its own. Caught in Venus's fast upper winds, high above the crushing heat and pressure below, each balloon rode the cloud layer for nearly 2 days, drifting roughly a third of the way around the planet before its faint signal finally died. Catching that signal took a kind of cooperation the Cold War rarely allowed. 20 radio observatories around the world, Soviet, French, American, turned their dishes toward Venus together, weaving the balloon's faint signals into one continuous track across the face of Venus. And then, the two spacecraft that had carried it all kept flying, past Venus, out across the solar system, onto an entirely different appointment, a comet named Halley. One mission, 2 worlds, months apart. Somewhere beneath Venus's clouds, a handful of titanium spheres have been resting in the exact same spots for more than 40 years. Almost certainly, they are all still there. No spacecraft has ever gone back to look, so no one can say what 4 decades of heat and slow, heavy wind have done to them. Only that no rain has ever touched them, because on Venus, no rain ever reaches the ground. The drops that form high in the clouds evaporate long before they land. Venera 13, Venera 14, their older siblings Venera 9 and Venera 10, resting where they went silent, beneath Venus's thick orange sky. No footstep has ever passed near them. They have now been silent far longer than any of them ever spoke. That is about to change. A new generation of Venus missions is being prepared. In the early 2030s, NASA's Da Vinci probe is set to drop through those same clouds toward the surface. The first descent toward that ground since the Soviet landers fell quiet, one by one, decades ago. Europe's Envision orbiter will follow, planned to study the planet in far sharper detail later in the decade. Until then, the landers wait. Not broken exactly, just finished, resting in basalt dust under a sky that never really changes. Every mission that reached Venus's surface bought only minutes. Someone, eventually, always goes back. Curiosity never stops. It only waits. This has been a story of the cosmos. Out there, the stories go on, slowly, quietly, as they always have. Let this one drift on without you until the next journey.